What if we do a transformation to a random variable? Transformation, ready, is a slide following a scale change. You did this in pre-calculus, you did it in calculus. It is. Except it's univariate data. So we don't have scale change of magnitude AB or slide of magnitude HK. We just have one thing to do to each. So this is saying the expected value, the mean, for the pre-image is mu. The standard deviation sigma. Yes, we did that in 6-1. But if we transform the data, what happens? It's a slide following a scale change. So the scale change magnitude D, this is C and D are from the text. We expand the mean by a factor of D and then add C. With a step, the slide's got nothing to do with it. Right? It's a measure of spread. So if I have the data that's from here to here, and I do a scale change to the data and then slide it, the slide does not affect the measure of spread. So you don't see this C for the standard deviation. So here's what they're talking about, which is how we're going to do. Suppose you are going from Fahrenheit to Celsius and the other way around. Well, you memorized this in middle school, but it's a linear transformation. What's happening? If we build this table where where the top line is freezing and the bottom line is boiling, we would have, for this freezing line, we would have 0 centigrade, 32 Fahrenheit. For the boiling line, we have 100 centigrade and 212 Fahrenheit. So in this scenario, the Fahrenheit temperature depends upon the Celsius temperature. And the slope would be, subtract up, the slope would be 9/5. And then the slide would be 32. Look what would happen. We would do the scale change first. Multiply 0 by 9/5, you get 0. Add 32. Multiply 100 by 9/5, you get 180. Add 32. Then if you wanted to go the other way around, if you wanted to get Celsius from Fahrenheit, you would undo the slide first before you undid the scale change. Okay? And if we're combining two distributions, now this is going to be repeated through the rest of chapter 6. If we're combining two distributions, we add the two means. If we want the difference between two distributions, we subtract the two means. Okay, this is pretty user-friendly. Until now. If we want the measure of spread, we add the variances. And we talked about this in 6-1. The variance is not, we don't use the quantitative value of the variance in the course, but you have to know what it is, because for the measure of spread, you add the variances, which is the value you get before you take the square root. And if you take the difference of two distributions, you still add the variances. Now, we're going to show you why that's true in the beta lesson. But the point is, the expected value of the center is pretty easy. Just add the center and you subtract the center. You never subtract standard or the variances. You don't do it. You add the variances if you're adding the distributions. You add the variances if you're subtracting the distributions. And then the standard deviation is the square root of that sum. So you have two problems to go to. 47 and 49 I'm going to pause this. All right, 47. Ready? It tells you this. The given information. 8.5 degrees Celsius is the center, and the standard deviation is 2.25 degrees. So I drew this picture, like we did earlier in the fall. And I didn't write the z-score, but this is a z-score of 0, z-score of 1, and z-score of -1. And I just counted out from the center, 8.5 degrees, add or subtract 2.25, which is the standard deviation which was given in the question, which is telling you what? Well, a little more than 2/3 of the time, the temperature in Celsius would be in this interval. So the first question is, all right, we got to do the transformation and draw the Fahrenheit distribution. Fahrenheit, this T chart, depends upon Celsius. So in order to get the center, we do the scale change first. So we multiply 8.5 times 9/5, and then we do the slide. And you would get 47.3 degrees. So 47.3 degrees is dead center. It's a z-score of 0 for the Fahrenheit distribution. What about the step? Well, it was given to you to be 2.25. We multiply that by 9/5. The slide has nothing to do with it. So the measure of spread is 9/5 times that, which is 4 5/5. So we can have 4 5/5 to the right, 4 5/5 to the left. So to say that a little more than 2/3 of the time, the temperature would be between 6 and 2,500 Celsius and 10 and 7,500 Celsius. It's the same thing as saying a little more than 2/3 of the time, the Fahrenheit temperature is 43 1/4 to 51 3/500. Well, what is this 4.05? This is the typical variation in temperature. Okay? So next, we go back to what we were asked to do before. What's the probability that temperature is below 40 Fahrenheit? If I look at this picture, 40 is over here somewhere. There's not a lot of room in the curve for that to be under 40. With one step, it's 43.25. That's going to be over here. Okay? You said, all right. Calculator on your desk. You go to, oh, I didn't show you this today. Sorry. Here's what happened on the test. So half the people got a perfect paper. The mean was 37 and change. That means one wrong, and you were entitled to remediation. I sent that on Saturday. That is due on Wednesday. That counts for the first marking period. You got remediation on the 5 test. So now what? We're going to go to second bars, normal CDF. Now, the first thing, somebody asked me this earlier, I guess they don't remember. The first number is a preset. If you have an older edition of the calculator, you don't get this preset. As long as you put a number to the left up there. So we're talking in this question about degrees in Fahrenheit. So I just put a number to the left. It's not z-scores. So I'm going to put in negative 100. Negative 100, you get to 40. Those are values below 40. That's what being is, yes? Then the prompt is, what's the center? The center is 47 3/10. You got that by doing the transformation to the center that was given from Celsius data. What's the step? That's the 4 and 500. That's what you want the calculator to do the work. And if you have an older calculator, you have to put those in without the prompts. So you would type left bound, comma, right bound, comma, center, comma, step. And if you have an older calculator, you have to remember that. That's how we got this answer on the PDF. But that's going to happen a little more than 3.5% of the time. The temperature would go below 40. That's the area under the curve to the left of 40. Now remember, we could do normal CDF draw. We don't want to do it for this problem, because if you do it for this problem, we either have to convert everything to z-scores, or we have to come up with a window specific to that problem. It's easier to just do the problem without the picture. You draw the picture yourself, freehand. The other question asks you to combine two variables. So we have two more pictures. You got this. If you had to pay two different tuitions, here's the main campus. So I marked it up again. Here's the center. $732.50. Suburban campus, $825. And then here's the steps. The steps are given to you, so I counted out. One to the right, one to the left. And the question becomes, you have another picture. And the other picture is combine them. So when you combine them, the center would be the sum of these two values. It would be $1,557.50.
Please pardon the interruption. Any students who have not had their picture taken yet today should please report to the auditorium at this time. Thank you.
So here's what's going to happen. The measure of variability of spread is for the beta lesson. But if you're in the room, we're going to have you calculate that. We're going to edit this picture, which is the combined distribution. If you're at home, you're dismissed to go do the exit ticket, and we will see you in the building tomorrow. You have 103. It's the one standard deviation. To get the variance, you have to square that. The 103 is what you got after you took the square root. To get back to the variance, you have to square it. Plus 126.50 is the standard deviation of the other campus. That's the standard deviation. You want the variance, you have to square it. There are the sum of the variances. The standard deviation would be the square root of that. Which is about $163.13. What does that mean? It means for this picture, we got 15, 57, 50 as the sum of the two means of the tuitions. And we're adding 163, 13, and we're subtracting it to get the values that would be here. So the rent is even down. One step to the left would be $1,394. One step to the right would be $1,721. So if you combine the randomly selecting one from each of the two distributions, a little more than 2/3 of the time, you would get values between $1,394 and $1,721. Okay, the $163 is how much they typically vary from the center. So